Good morning, calc fans. How we doing this morning? It's a little chilly outside, a little cloudy, a little windy still. Hopefully you're able to get outside this weekend, enjoy the nice weather. It was really nice just to be able to open up the windows in the household, let the house air out a little bit. It was nice. Hopefully we'll get some more weather towards the end of this week and next week. That's going to be nice. It's supposed to be chilly here at the beginning of this week, but it's okay. It's still March. Hopefully everybody is doing well in your household. Hopefully you're feeling okay and all your family and relatives are feeling okay. Please remember to continue to do your social distancing. Keep away from each other in regards to the social aspect. The more social distancing we can do, the better off it's going to be, and hopefully we can get back to normal as quickly as possible. So hopefully everybody's doing well in your household. Once again, if you have any questions, at all, feel free to email me any of your questions. I'm going to highlight one of the problems from the worksheet on Friday I gave you. Today I have posted already a review sheet. We will have a quiz tomorrow over Newton's method, differential equations, and indefinite integrals. That will be tomorrow. Tuesday, Wednesday, and Thursday will be review days. To prep for a chapter test that will be on Friday of this week, and that will take us right into spring break. Once again, University of Findlay is asking us to continue to push everything forward, so we're going to keep this ball rolling in the class. Once again, if you have questions, feel free to email me these questions as you go along. I'm going to highlight this problem here, problem number 2 from the worksheet. So if you don't have your worksheet out, and you'd like to get it out and work on this, go ahead and push pause, get everything out. You will also need your calculator to be able to get through this. Now, what we have in this is we want to solve this for Newton's method. Okay, we are solving this for Newton's method. We have this as a value of 0. We want to be able to solve this to be able to come up with possible x-intercepts in regards to how the x-intercepts and graphing. Newton's method basically is what your calculator will do. Okay, if you remember what we did with Newton's method, we had an initial first guess that we were going to deal with, and from that point on we guessed more and more other values. Your calculator does that also. When you go to find your zeros on the graph of a function, it asks you for a left and a right area or guess, left and right. It gives you an initial guess, and then it allows it to go through Newton's method. But it does a little bit quicker than we do. Now, certain things that we have to take a look at. We have a trig function here. We have an ln function. Now we have trig function, we have x. What we have to make sure of is that we talk about the idea of radians here. When you were in trig class, we talked about a little bit about why radians were important. Why couldn't we just do everything in degrees? The problem that you run into in radian or in the degree mode is upper level calculus starts to fall apart. Okay, calculus starts to fall apart in the degree mode. So what we have to do is change it into an XY mode, which is your radian mode. So let's first make sure our calculator, let's clear out of here, let's go to our mode, make sure that we are in our radian mode up here. Okay, so go ahead and check your calculator and make sure you're in your radian mode. If you're not, if you get down here and your calculator looks like that, it's in degree mode. Okay, just come down, highlight the blinker on the radians, hit enter, and that takes us into our radian mode. Now, with our Newton's method of solving this equation, I also gave us a domain that we're only looking for zeros between the value of 0 and 8. If you remember back, we have xn plus 1 is equal to xn minus f at xn over f prime of xn. Okay, and that was Newton's method to be able to solve this equation. And if you been following our notes and our lectures that we've been dealing with, and we went over Newton's method, what we did also in that is in our y, let's that. If we go to y equals, what we did is we put in Newton's method in y3. y1 and y2 were your original function and your derivative. Okay, so y1 was our original function, y2 was our derivative, and when we plug the values in for x, here's our y1, which is our function value, and then here's our function value at our derivative. So if you've not typed that in, go ahead and type that in, and if you haven't been following along the notes, you should be able to go to the Newton method notes that we had in the Google Classroom. Go to your Newton method notes, and it will show you how to type that in. Okay, so that will be something that will be very, very important as we go through this problem. Now, what we have here is we have our function. Newton's method is also dependent on the derivative. So we have to take the derivative of our function here. Well, we have the derivative of cosine. Now remember, the derivative of cosine is negative sine. Plus the derivative of the natural log, which is 1 over x. Then the derivative of our constant is the value of 0. Now remember, we're taking the derivatives, not the antiderivatives. And that tends to be sometimes the confusing part, because we've been dealing with the antiderivatives the last few days. Now we're looking at the derivatives again, and sometimes you'll tend to get those things confused. Once again, we are looking for values here between 0 and 8. Now, what we've talked about before is we need to have an initial guess. Well, how do you come up with an initial guess? Well, what we can do in our calculator, and this is fine to do in your calculator, is come up with an initial guess by looking at the graph of our function. So we're going to want to type in our function cosine of x plus ln of x minus 2. So we have cosine of x plus the ln of x minus 2. Okay, so we type that into our y1. Make sure I did that right. Plus ln of x, that's correct. Now what we can do with this is we can go to our graph. Okay, if we take a look at our graph, we get a little funky graph there. We can get our initial guess. We have the value of 1, 2, 3, 4, 5. Between 5 and 6, we will have a value, a 0. If we take a look also, let's see, that's 5, 6, 7, 8. Between 7 and 8, we also have another value. So we take a look at our graph of our function, and we can narrow down between 5 and 6 and 7 and 8. We have 2 0 values because we crossed the x-axis. Now, in our function, in our y2, we are going to want to type in our derivative. So if we look at our derivative, we have the negative sine of x plus, let's see, I put it in parentheses, 1 divided by x. Don't think we need to do that, but I'm going to. Just because I get paranoid that my calculator is not smart enough. It is, but it's okay. So we have negative sine of x plus ln of plus 1 over x. And that would be our derivative. We have to start with an initial guess, our x1. In our x1, what we want to do is, if we take a look at our, oh boy, I don't want that. it looks like we're fairly close to the value of 5. So what I'm going to do with my whole number is my first guess is the value of 5. Now if you remember what we did from this point is we went, okay, if my x is a value of 5, so I take my value of 5, I store it to x. Okay, so my x value that I have is the value of 5. Now what we want to calculate is we want to calculate our y3 value. So I can get my y3 parenthesis at x and hit enter. And this gives me my next value. So we have, what I want you to do is I want you to copy that entire value down. 5.09224. Oh, tartar sauce. And so on. Type it all down. We use x2 to give us x3. Sort of like a recursive formula with the sequences. So what we want to do now is we want to store this to our x. We hit enter. And I want to be able to calculate this y3 of x again. So I don't want to go back and find my y3 again. So I go second entry, second entry, and it gives me my y3 of x again. So I hit enter, and I get 5.903573255. Once again, I want you to write down all those values. And if you look at my notes or look at the solutions of the worksheet, you see I have all the values there. We're close to our value, but you go and you continue this until we have the identical values what we had in the previous step. So what I have is I'm going to store this to my x. Second enter, and I pull back my y3 of x. And if I take a look, I almost repeat every digit. Okay, I got 285 and 609 here. So I would tend to guess my next value that I sub through there is going to give me a repeater. So I'm going to store to x. Second entry, hit enter. And as we guess, we'll start to repeat, and that's what we want. So this here is a 0 to the function. Okay, this here is a 0 to the function. This is where my graph intersects the x-axis. And once again, this is what your calculator does. I remember when I was in college, when we had to do basic programming. In my basic programming class, we had to program this Newton's method out. Because if you take a look, okay, once again, write out all the values. If we go to our graph, okay, here's our graph. And if I want to calculate a 0 value, okay, we have the darn blinking spider. We want to have a left bound. So I put a value here, and then I take it to the right bound and hit my enter again. And this sort of tells us the values that were in between. That gives me this right here. I'm saying somewhere between 5 and 6, I'm going to get a value. And if I hit enter, okay, before I hit enter, it gave me a guess. So let's take a look at that again. Okay, second calculate. I'm going to calculate my 0. I have my left bound. I hit my right bound. And it gives you this guess. This here is the initial guess. This is your x1 in your calculator. Now your calculator goes through Newton's method to be able to determine that value that we calculated here. So you're basically doing Newton's method is what your calculator will do, and the guess that you have up here is that initial guess. what I want you to be able to do is I want you x4, x5, x6, just give me those x values. I don't have, give me the derivative, and give me your boundary values for that value of 0. And you can get your boundary values once again by looking at your calculator. Now, if you use one of these values and all of a sudden it goes haywire and the values start going crazy, and it's not getting a value between 7 and 8, okay, what I would suggest you maybe try the other value. If that still does the exact same thing, then maybe take 7.5 and try that value then. Because sometimes Newton's method will go off on a tangent somewhere and give you this different values. Don't worry about that, just try a different value. But once again, what I expect you to do is I expect you to list all these values. And these values, if I start with this value within the calculator that you started with, I should be able to run it through Newton's method and come down with these values step by step by step. Okay? So I should be able to come down to the exact same values you do. Hopefully that helped you out with the Newton's method. We also have antiderivatives, and also we have the differential equations. I posted an example problem with the differential equations and the slopes also on Friday. Hopefully those are helpful for you. Once again, we will have a quiz tomorrow. I will post it tomorrow. Please have it done by the end of the day, by midnight or so, tomorrow evening. Get it done and completed. Wednesday and Thursday, once again, will be review days, and Friday we'll have a chapter test over chapter 4. Okay, that will complete us up till spring break. When we come back from spring break, whether we're classroom or what are we doing at that point, who knows. We will start into chapter 5, which is all just basically integrals and antiderivatives. It'll be a couple weeks, 2-3 weeks, we'll be able to get through that. So hopefully by the middle of May, we will be completed with all the material that we need to be able to cover. If you have questions about any of the other problems, feel free to email me. I will respond back, or we will highlight the problems here in class as best as possible. But please do keep up with the material. Once again, I hope everybody is safe in your household. Hope you're staying safe. Please do keep your social distancing. Allow us to be able to get back to some sort of normalcy. I miss you guys. I wish you were back here in my classroom. But it's our reality right now. So we'll just make the best of what we do. It's not exactly our plan A, but that's fine. We go to plan B and we'll be able to get through this. Stay safe, keep your social distancing, maybe get some Double D ice cream today. Make sure you call the order down now. Okay, if you have any questions, please do feel free to email me. That's all I have for today. Please work on the review sheet. Adios, have a great day.